What if everything you've heard about EcoBoost engines is about to become outdated? For years, Ford's EcoBoost lineup promised the perfect balance: smaller engines, turbocharged power, better fuel economy, and lower emissions, all without giving up performance. On paper, it looked like the future of engines, and in many cases, it delivered exactly that. But in the real world, things didn't always go according to plan. While plenty of drivers enjoyed strong performance and efficiency, a growing number of owners started reporting serious issues. Over time, these problems built a reputation that no automaker wants, one that many began calling the EcoBoost nightmare. We're talking about coolant leaks into the engine, carbon buildup choking performance, turbo failures happening earlier than expected, oil contamination, timing issues, and inconsistent long-term durability. These weren't isolated complaints, they became patterns. And that's where everything started to shift. Now, Ford says that chapter is officially closed. With the confirmed 2027 EcoBoost updates, the company claims it didn't just patch a few weak spots. Instead, it completely reworked the engine from the inside out, using over a decade of real-world data, failure analysis, and customer feedback. This isn't a minor update. According to Ford engineers, this is a full reset. So in this video, we're breaking it all down. What actually went wrong with earlier EcoBoost engines? What Ford has changed for 2027? And why many experts believe this could finally restore trust in one of Ford's most important engine platforms. To understand how big this change really is, we need to go back to where things started slipping. EcoBoost engines were built with ambitious goals. By combining turbocharging with direct fuel injection and smaller displacement, Ford aimed to meet strict emissions rules while still delivering strong power. Early success pushed EcoBoost across nearly the entire lineup, from small cars to full-size trucks. But scaling that technology across millions of vehicles revealed weaknesses that didn't show up in early testing. One of the most serious problems was coolant intrusion, especially in certain four-cylinder engines. Under real driving conditions, heat and pressure caused stress inside the engine block. Over time, this stress could lead to tiny cracks forming between coolant passages and the combustion chamber. When that happened, coolant would leak into the cylinders. The result? Misfires, white smoke, rough starts, and in many cases, complete engine failure. At the same time, another issue was quietly building up, literally. Carbon deposits began forming on intake valves. Because direct injection sprays fuel directly into the combustion chamber, the intake valves no longer get cleaned by fuel. Instead, oil vapors from the engine settle on those valves, creating thick carbon buildup over time. That buildup restricts airflow, reduces power, and causes rough performance. Then there was turbo reliability. Some units lasted well beyond 150,000 miles without issue. Others didn't make it nearly that far. Heat management, lubrication, and operating conditions all played a role, and not always consistently. Add in oil dilution problems in colder climates, and it's easy to see why confidence started to drop. According to experienced technicians, the problem wasn't the idea behind EcoBoost. The concept itself was solid. The real issue was underestimating how these engines would behave over years of real-world use. Different driving habits, extreme temperatures, long-term wear, and maintenance patterns. And that realization led to something critical inside Ford. By the early 2020s, the company had collected massive amounts of data: warranty claims, repair records, oil analysis, and engine teardowns. When engineers compared failed engines to high-mileage survivors, clear patterns began to emerge. At that point, it became obvious. Small fixes weren't going to solve this. Ford needed a complete rethink. Inside Ford, that realization triggered one of the most aggressive engineering overhauls the EcoBoost platform had ever seen. This wasn't about quick fixes anymore. Engineers were given a new priority: build an engine that could survive worst-case conditions, not just perform well under ideal ones. Every major failure point was re-evaluated using real-world data, not just lab simulations. And it all starts with the foundation of the engine itself. For 2027, Ford redesigned the engine block to directly address one of the biggest problems: coolant intrusion. The new block features stronger cylinder walls, improved material composition, and a revised internal structure designed to handle heat and pressure more effectively. In simple terms, the engine is now built to stay stable under stress. By reinforcing the areas that used to flex under high temperatures, Ford has significantly reduced the risk of microcracks forming inside the block. That alone targets one of the most catastrophic failures seen in earlier EcoBoost engines. But they didn't stop there. The head gasket, another known weak point, has also been completely reworked. The updated design uses stronger multi-layer materials that can better handle repeated heat cycles. This helps maintain a tight seal even after long-term use, preventing leaks that previously led to serious engine damage. Then comes one of the most important upgrades: cooling. Engineers discovered that uneven cooling was creating hotspots inside the engine, especially under heavy load like towing or hard acceleration. Those hotspots were silently accelerating wear and increasing failure risk. So for 2027, Ford redesigned the entire cooling flow. Coolant now moves more evenly throughout the engine, reducing temperature spikes across all cylinders. The system also responds more dynamically, adjusting based on real driving conditions instead of fixed limits. This means better temperature control, not just under stress, but all the time. And better cooling doesn't just prevent overheating, it protects everything. Oil lasts longer, turbo components stay healthier, and internal parts experience less long-term fatigue. Speaking of long-term issues, Ford also tackled carbon buildup, one of the most common complaints from EcoBoost owners. The updated system reduces the amount of oil vapor entering the intake, which is the main cause of carbon deposits. Airflow inside the engine has also been refined to prevent buildup from forming in the first place. While the engine still uses direct injection, smarter calibration now improves combustion efficiency, reducing soot and keeping components cleaner over time. The goal is simple: less buildup, fewer cleanings, and more consistent performance. Turbochargers also received major attention. For 2027, Ford improved turbo materials, lubrication pathways, and heat protection. These upgrades help prevent oil breakdown and reduce wear on internal bearings, especially during high load or sudden shutdowns. Boost delivery has also been refined. Instead of aggressive spikes that stress the system, the engine now builds power more smoothly. You still get strong acceleration, but with less strain on critical components. This approach is already common in heavy-duty and performance applications, and now it's being applied here for durability. Then there's the oil system, another area that couldn't be ignored. Ford introduced improved piston ring designs to control oil more effectively and reduce fuel contamination. Injection timing has also been optimized to prevent excess fuel from washing into the oil. On top of that, oil flow inside the engine has been fine-tuned to ensure key components, like cam systems and turbo bearings, get consistent lubrication under all conditions. The result is cleaner oil, more stable performance, and longer engine life. But one of the biggest upgrades isn't something you can even see. It's the software. The 2027 EcoBoost engines now use smarter engine management systems that constantly monitor temperature, load, and overall conditions in real time. The engine can adjust itself instantly, reducing stress when needed and maximizing efficiency when possible. this adds an entirely new layer of protection. Because today, engine reliability isn't just about hardware, it's about intelligence. And Ford is finally using that to its full advantage. So the big question is, did Ford actually fix the EcoBoost problem? Or is this just another promise? According to many experts, this time feels different. Independent engine builders, fleet managers, and powertrain specialists are seeing something they didn't see before. Instead of reacting to failures after they happen, Ford has gone after the root causes from the start. That shift matters. In the past, updates often felt like temporary solutions, fixing one issue while another slowly developed. But the 2027 redesign takes a more complete approach, strengthening the engine in the exact areas where real-world data showed consistent weaknesses. And that's why there's cautious optimism across the industry. Fleet operators, who rely on long-term reliability across hundreds of vehicles, are especially interested. Early internal testing suggests lower wear rates, better consistency, and fewer failure patterns over extended mileage simulations. If that holds true in real-world driving, it could be a major turning point. For buyers, this changes the conversation completely. There are a lot of people who avoided EcoBoost engines because of what they heard: stories of failures, expensive repairs, and unpredictable reliability. And honestly, those concerns weren't baseless. But now, Ford is making a strong case that things are different. If these 2027 engines deliver as claimed, buyers may no longer have to choose between performance and peace of mind. You could get turbocharged power, solid fuel efficiency, and long-term durability in one package. For current owners, this also sends a clear message. Ford isn't ignoring the past. The company has studied it, learned from it, and used it to build something better. While older engines won't magically transform into the new design, this level of transparency and engineering effort shows a serious commitment to improvement. And that's something the brand needed. Because in today's market, trust is everything. The EcoBoost name was once associated with innovation and smart engineering. Then it became linked with uncertainty for many drivers. Now, Ford has a real opportunity to rebuild that reputation. But let's be real for a second. No engine is perfect. No matter how advanced the design is, long-term reliability will always depend on real-world use, maintenance, and time. The true test for the 2027 EcoBoost engines won't be what's claimed today. It'll be how they perform after 100,000 miles and beyond. That's where the real verdict will come from. Still, this is the first time in years that experts are genuinely optimistic, because this isn't just an upgrade, it's a full correction. Ford has reinforced the engine's foundation, improved cooling and oil systems, strengthened turbo reliability, reduced carbon buildup, and added smarter control through software. All of these changes work together, not separately, to create a more durable and balanced engine. And that's the key difference. This isn't about chasing numbers anymore. It's about building something that lasts. The EcoBoost story has been a mix of ambition, innovation, and hard lessons. Ford pushed forward with advanced technology, but real-world challenges exposed the limits of early designs. Now, it looks like those lessons have finally paid off. If the 2027 EcoBoost engines live up to expectations, this could be remembered as the moment Ford turned things around, transforming a troubled reputation into a reliable, modern powertrain. And maybe, just maybe, the EcoBoost nightmare really is over.